Coffee with Kusari. I'm Ben Cotton, and this time we're with Parth Patel, co founder and chief product officer at Kusari. So, Parth, Kusari just announced a pretty awesome little tool called Kusari Inspector. Can you kind of tell us what that's about?
Sure. Yeah, Kusari Inspector was, made from necessity. So if I take you back to when I first started, when I first started my career, I was working at Raytheon. Raytheon has a very outdated method of figuring out if dependencies should be allowed in their organization or not. So it was very much a black box process where a developer would, submit a request for a specific version, and then a couple weeks later come back with an approved or not approved. And, they did, I'm not sure what they did behind the scenes, but they did some kind of analysis behind the scenes to figure out, hey, should this be allowed in our organization or not? Right. So that took a very long time, and the developers were very, very interrupt driven. They would take a long time for can I use this or not? And then eventually maybe it comes back with, hey, you can't actually use this or you can't use it. And then now you got to start the whole process all over again, right? So there was an approved list to begin with, but if you wanted to add anything new, it would take a very long time. So, it doesn't offer the flexibility that a developer may need. So, it's because of this slow process, and I saw this happening in a lot of other organizations that I worked at. You know, we need this information. The developers want this information up front, or even the security team may want this information up front, instead of them doing their due diligence on their own, which can be very hard, very time consuming. Figuring out whether a specific license is an issue, whether does it contain vulnerabilities, is it typo squatted, is it outdated, what is it like, what's wrong with it, is it being maintained well, like all these kind of questions someone would have to physically manually go do, right? And it takes a very long time. So our goal for the Kusari Inspector is, can we provide this information right away to the user? So whenever you create a PR, can we right away tell you, are you safe to use this dependency, right? We're going to check to see if the license is, is it open source friendly? Um, are there any critical vulnerabilities associated with it? Is it the latest version? How well is it being maintained, right? We're using a lot of, we're part of the OpenSSF. All the co-founders, actually, the most of our team on Kusari side works a lot with the OpenSSF, right? So we work together with Scorecard. There is information from OSV, Dev. There's a lot of information out there, but it's not easy to query and easy to obtain for specific needs. So that's what we wanted to do, is provide, you know, context and information right away to the developers as they're writing the code to tell them, hey, should I be using this particular dependency? Is there any kind of issue associated with it? And then have our AI come back with a go no go, basically saying, like, hey, yep, you're allowed to go forward with this, and it takes into account like all the dependency trees and dependency analysis all around it, right? It's not a simple question as, hey, this particular dependency is bad. It's going more in depth into thinking about it from a holistic perspective about where is it in your dependency tree, how well is it being maintained, as well as, okay, is it coming in as a transitive dependency of some other well-known package that I trust this package, but okay, this one is a little bit less maintained, but I trust this package and I know that developers are doing the right things, that it'll never come to me from my code will never get affected by it because I trust that layer above it, that is a very trusted, very, very secure project that I'm pulling in, and it's using it as a transitive dependency on their side. So it's taking all this information into account, the whole dependency graph, and then giving you a go, no go, and all the information you need to kind of go forward with it. So that's the dependency piece. And then at the same time, we wanted to do, security analysis on the code itself. Make sure you're not doing anything, SQL injections, anything that you may regret or the security team may find later on, right? Secrets, all this kind of stuff. Uh, can we just catch it early and tell you right away, hey, it's there. Uh, you know, don't do this. Don't go forward with this. Make the fixes first. This way, you kind of go forward with it. So.
Okay. Can you say a little more about the transitive dependency piece? Because I know that's something a lot of tools in the supply chain security space don't necessarily address, and it seems like, for us, that's one of our, real key differentiators. What makes doing transitive dependency analysis hard, and, how do we sort of solve that?
Yeah, so dependency, right? So dependencies can go layers deep, right? And that's where the transitive dependency piece comes in. It's like you're not looking at the first layer dependencies, you're looking at level, third level dependencies. So how do you ensure that a project, a first level dependency you're using, how do you ensure that just, if things below it are also secure, right? Because there could be an attack vector from those particular transitive dependencies that are layers down that could still cause an issue on your side. So that's where we're using information coming from tools such as deps.dev. We're mapping out your especially in inspector, we're mapping out your dependency file directly, your package lock, for example, requirements.txt, all those kind of files. We're mapping it all out to figure out exactly what the dependency tree actually looks like based on some of this open source information that we have. And then from doing that, we can actually figure out, okay, yes, this particular dependency that is vulnerable is actually coming in because of this. Maybe it's a test dependency that you're using, and that's where it's coming in. Testify, for example. So should you be worried about it? So all that analysis is very complicated, and not a lot of systems, not a lot of tools actually do this currently because it's very complicated, and the dependency chain can be very complicated to deal with. So we're doing that analysis behind the scenes for you so that you have a clear picture at the PR level, a clear picture of how your dependency is being used, where is it coming from, and then, any kind of issues associated with it.
At KubeCon Europe this year in London, we were showing off, an early version of Kusari Inspector, and people really seem to get it. What kind of feedback have you had from the pre-release testers and things like that that have kind of made you say, "Oh yeah, this is the right thing"?
So I think it's one thing is the ease of use, right? You just uh, install it, pick which repositories you want it to install on, and then that's it, right? There's no real setup that gets involved. Because we are coming in, as the being part of the open source, Guac maintainers, working with the OpenSSF, dealing with all these other open source, other software supply chain security projects like Tecton Chains and so forth. We're coming in as the experts, and we're basically like, okay, how do we ensure that what does the user need in order to feel secure about their dependencies and all those and their source code, right? So we're building in all these guardrails. We're building in all our knowledge, behind the scenes, so that all the user has to do on their side is install it, and then they're kind of protected from from our expertise around the space of like what you should be looking out for, what is considered safe, what is considered not safe, how do you want to look at it from a larger picture, how do you want to analyze some of this data? So we're doing all that stuff behind the scenes, and with the use of our AI, we can provide this information very easily and cleanly to the user so that it can give a clear go, no go. And I think that's from a lot of the comments is people are this was something that was missing, right? Is it was like, yeah, they would catch it after the fact in a scanner, or they would catch it in some other kind of tool later on. But being able to catch it up front at a PR level is much more important because the developer can make the choice right away about like, hey, I should make a change right here instead of waiting for like a security team or someone else to come back to them being like, hey, a week later, hey, this dependency is actually pretty bad. If you had using Spectre in the first place, you would have known this and you could have made the change right away, kind of thing. So.
The use of AI is a kind of divisive topic in the tech world right now. There's a lot of people who are very enthusiastic about using AI in all kinds of applications, and there are people who are what's hesitant at best or outright opposed. So how have you made sure that the AI analysis that sorry Inspector provides is reliable and trustworthy?
So we are grounding our AI analysis on well-known, well-established tools that are out there for security, right? So we're using, like I was saying before, we're using open source tools that are out there. For example, we're using OSV for our vulnerability database. We're using deps.dev, and then we're using a lot of other security tools behind the scenes to evaluate the code, the dependencies, all these kind of places before we send it to the LLM to analyze the data. So we're not letting the LLM do its own analysis, right? Because the LLM will not have a lot of the information that it needs in order to make a proper decision. Because even if it goes out and searches on the web, it's not going to find proper information about a particular dependency. How is it interconnected in this web of in this dependency graph that is particular to you, right? So the context about how is the dependency graph look for you specifically, and then how is that all interconnected for you? That is an important piece that the LLM by itself cannot do. And we're making sure that it has all this proper information, has all the proper context with, ensuring that we're using other well-known security tools that can back up some of this claims so that the LLM will not hallucinate a lot of this, you know, avoid the chance of the LLM being able to hallucinate anything. So we're adding in, context that allows it to be much more accurate than just having the LLM figure it out all on its own.
How has using Kusari Inspector internally, during the development process, like, is there sort of a story of like, wow, this really, caught something I never expected?
Yeah, I mean, there's actually a lot of cases that's actually, we're going through, we internally try to maintain zero exploitable vulnerabilities on our side. So we're always ensuring like, hey, we always make sure that is there any kind of, if we're pulling in new dependencies or working on new features, are there any dependencies we're pulling in that are problematic? At the same time, we're doing updates and all that kind of stuff. You can see, oh yeah, we're resolving some of these vulnerabilities that may have existed. So we can catch them we can catch them quickly before they make it into the code base, and then resolve them very quickly. At the same time, some of the best practices, right? Because we're moving very quickly, as a small team, as a startup, we want to move quickly, get the features out there. We want to ensure that we still want to make sure we're following security best practices. So, having the inspector kind of help us like, hey, you should be doing something else. Like, you could expose a secret here on the Docker file, or, we're writing, Helm charts or Terraform, whatever else it is. It's like, hey, you should be doing this to ensure that, secrets don't get exposed. All these kind of checks are actually happening, and we're actually using them. So our developers are actually behind the scenes are making the changes before they actually merge. So it's helping us internally, even as a security company, to be better, right? Uh, that every team wants to move quickly, but we want to make sure like provide the guidance that the developer needs at the right time, and then they'll make the changes, right? Your developers are not uh, they don't want to fight security as long as it's like, can it be easy for them to implement? If you tell them at the right time, they'll happily make the change because it's less work for them in the future. So I think the goal for the inspector is also to train them to be better, right? So eventually, the ideal state I would want to be, I would want to see is like the inspector comes back with nothing because the developer has learned, like as they're writing a new Docker file, it's like, oh yeah, last time I remember the inspector told me that I shouldn't be using secrets in this way, or the Terraform, I shouldn't be using secrets in this way. I should be doing it this way. Then, we're teaching them best practices, and then eventually in an ideal state, inspector comes back with nothing, right?
So, can you talk about what's maybe coming next for Kusari Inspector?
Yeah, I think so. The goal for that I want from inspector is have people start adopting it, have people start using it, and then provide feedback on what else they would like to see. Right? Some of the early beta testers that we've been talking to, that have been using Inspector have said, "Hey, I would really like to be able to do like a nightly scan to get like a baseline of like where am I in my security journey, right?" Because the inspector's coming at a PR level, they don't know how secure or how well established is their baseline for their actual source code, right? Like how secure is my repo in the first place? So what they would like to see is like, hey, give me a report, maybe monthly, whatever it is, that tells me like, hey, these are the issues. This is where you are at in terms of a security score, or like a security state of your particular, repo. And then now, once you resolve these things, the inspector will ensure that you stay at that baseline of a secure state.
So, you talked about using, potentially having like a regular scan from Inspector to get sort of the whole application view. Can you talk about how Kusari Inspector can work with the Kusari platform to help provide some of the bigger picture work?
Yeah, so if you can think about it, the Kusari inspector and the Kusari platform as being in like in watching your back, and at the same time, if anything help happens in the future, the Kusari platform is there to catch everything, right? So your first level of defense is the inspector. So as you're developing new things, are you bringing in anything that could be cause for alarm, right? But vulnerability landscape is always ever changing, right? So at one point at the Kusari inspector time, at your PR time, a vulnerability may, there may be no vulnerability, but now in the future there might be something, right? There might be a vulnerability now. So that's where the Kusari platform would come into play. So you can think about it as like a holistic view of your software supply chain security. So, where the PR is it's the inspector's catching it early. The Kusari platform is checking to, where once this actually gets deployed, once you actually push it into production, whatever else, where is it running? Is there a new vulnerability that I discovered, like I discovered today? How is it affecting you? Is there exploitability, VEX, vulnerability exploitability exchange data out there that could tell you that are you actually affected by this or not? So all this kind of information we would provide at the Kusari platform side. So if you think about it, if you have the full Kusari platform and inspector running all at once, we can feed some of this data back into inspector. So once we have an analysis of how exactly a particular package is being loaded into memory, for example, is it being utilized at runtime, we can come back to the PR level, and in the future, if a particular vulnerability comes out for that particular package, we can be like, hey, based on the VEX data we received at runtime, you're actually not utilizing this package at runtime because it's not being utilized in production. It's not being loaded into memory. So there's a vulnerability, but you can deprioritize it a bit because it's not really a big deal. So it won't get blocked for that reason. So it gives you the whole complete picture all the way from production all the way to your source code, how everything's all interconnected. So that's what the complete picture. But you can also use Inspector by itself, right? Or you can use the Kusari platform by itself.
All right. Thanks, Parth, and thanks everyone for watching. If you want to learn more about Kusari Inspector, we have a webinar coming up on July 16th, and you can see details and information about Kusari Inspector at kusari.dev.